Our universe is vast, mysterious, and full of wonder. But it wasn't always this way. Scientists believe everything started with a bang, the Big Bang. Imagine all the matter and energy of the universe compressed into a tiny point.
Then, about 13.8 billion years ago, boom! This explosion created space and time as we know it, sending everything hurtling outward. The early universe was incredibly hot and dense. As it expanded and cooled, particles began to form.
First came simple elements like hydrogen and helium, the building blocks of stars. Gravity then began to pull these elements together, forming giant clouds of gas. These clouds collapsed under their own gravity, getting hotter and denser.
Eventually, the pressure and temperature at the center became so intense that nuclear fusion ignited and stars were born. These early stars were massive and short-lived, eventually exploding as supernovas. The Big Bang was not just a random explosion, it was an event governed by laws of physics.
These laws, which we are still striving to fully understand, shaped the evolution of the universe and continue to govern its expansion today. Stars are the cosmic furnaces where heavier elements are forged. Within their fiery cores, hydrogen atoms fuse to form helium, releasing enormous energy. This process continues, creating elements like carbon, oxygen, and iron, the elements essential for life.
When a star runs out of fuel, it dies. Massive stars end their lives in spectacular supernova explosions, scattering newly formed elements into space. These elements become part of vast clouds of gas and dust called nebulae.
Gravity continues to play its role, pulling material together within these nebulae. As a cloud collapses, it begins to spin, forming a disk of material around a central protostar. Within this disk, dust grains clump together, growing larger and larger over time.
These clumps eventually become planets, their composition influenced by their distance from the star. Close in, rocky planets like Earth form. Farther out, gas giants like Jupiter and Saturn accrete vast atmospheres of hydrogen and helium.
Our Earth is a remarkable place, teeming with life in countless forms. But how did it all begin? About 4.5 billion years ago, Earth was a hot, molten world. Over millions of years, the surface cooled and solidified, forming the first continents and oceans.
The early atmosphere was very different from what we breathe today, lacking oxygen but rich in other gases like methane and ammonia. Yet, within this primordial soup, the first signs of life emerged, single-celled organisms that could harness energy from their surroundings.
Over billions of years, life evolved and diversified. Photosynthesis evolved, releasing oxygen into the atmosphere and paving the way for more complex life forms. From simple bacteria to plants, animals, and eventually humans, life on Earth represents a continuous chain of evolution.
The evolution of intelligent life is a testament to the incredible power of natural selection. The conditions on Earth, while seemingly ordinary in the grand scheme of the universe, provided the perfect crucible for life to arise and flourish.
The search for life beyond Earth is one of the most profound quests in science. But where should we look? Not all stars are created equal when it comes to supporting life. A star's size, temperature, and lifespan all play a role.
Around each star is a region called the habitable zone, also known as the Goldilocks zone. This is the sweet spot where temperatures are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. Liquid water is considered essential for life as we know it.
The size and location of the habitable zone vary depending on the star. Smaller, cooler stars have closer and narrower habitable zones, while larger, hotter stars have wider and more distant ones. Our Sun, a middle-sized star, has a habitable zone that encompasses Earth's orbit.
Astronomers are actively searching for planets within the habitable zones of other stars using telescopes like Kepler and TESS. These telescopes detect the subtle dimming of a star's light as a planet passes in front of it, allowing scientists to infer the planet's size and orbital period.
While the search for life beyond our solar system continues, our own cosmic backyard offers intriguing possibilities. Mars, the red planet, has long captured our imagination as a potential abode for life. Evidence suggests that Mars was once a warmer, wetter world with rivers, lakes, and perhaps even oceans.
Today, Mars is a cold, dry desert, but scientists believe that water ice may still exist beneath its surface. The presence of organic molecules, the building blocks of life, has also been detected on Mars. These discoveries fuel the hope that microbial life may still exist on the red planet, either on the surface or deep underground.
Beyond Mars, the icy moons of Jupiter and Saturn hold tantalizing possibilities. Europa, a moon of Jupiter, is thought to harbor a vast subsurface ocean of liquid water, perhaps twice the volume of all the Earth's oceans combined. This ocean is shielded from the harsh radiation of space by a thick, icy shell, but hydrothermal vents, similar to those found on Earth's ocean floor, may provide energy for life.
Similarly, Enceladus, a moon of Saturn, is known to have geysers that erupt from its south polar region, spewing water vapor and organic molecules into space. These geysers suggest the presence of a subsurface ocean, making Enceladus another promising target in the search for extraterrestrial life. The question of whether we're alone in the universe has fascinated humanity for centuries. Philosophers, scientists, and dreamers alike have pondered the existence of life beyond Earth. As we continue to explore the cosmos, we inch closer to answering this age-old question.
The notion of conscious existence in other parts of the universe challenges our understanding of life itself. If life exists elsewhere, it may be fundamentally different from what we know. The discovery of extraterrestrial life would not only expand our knowledge, but also reshape our place in the cosmos.
Whether microbial or intelligent, the discovery of life beyond Earth would be one of the most significant milestones in human history. It would open up new realms of scientific inquiry and philosophical reflection, forever changing our perspective on life and the universe.
As we gaze at the stars and wonder about our place in the universe, we must remain open to the possibilities that lie beyond our current understanding. The search for life is not just a scientific endeavor, but a journey of curiosity and wonder, reminding us of the boundless potential of the cosmos.